Here I have drawn a periodic function, which has a period of 360 degrees. This is clearly very similar to a sine or cos function. The only difference is that it's been stretched in the y direction and shifted along the x-axis. For that reason, we can write the general equation of a curve like this as follows, with the r having the stretching effect and the alpha the shifting effect on the original function. Since it can be a stretch and a shift of a sine or a cos function, you could write it in either form. This is called the harmonic form of a periodic function. Interestingly, it turns out that we can also write this general periodic function as a linear combination of sine and cosine functions. That is to say, by adding together some amount of sine curves and some amount of cos curves, we can always result in a graph that looks like this curve. We write this general form as a sine x plus b cos x, with a and b unknown constants. Both of these are legitimate ways of expressing this 360-degree periodic curve, and so we must be able to interchange between the two. In exams, we are usually given the values of a and b and asked to find the constants r and alpha. The procedure to do this is quite simple. First, recall our list of angle addition formula from the last video. We take whatever harmonic form that we have been asked to use and write it out in terms of simple sine and cosine functions using the relevant angle addition formula. Now when we expand the bracket and reorganize our terms, we find that this expression can be written in terms of sine x and cos x, with coefficients in terms of r and alpha. Since we want our solutions to hold for all values of x, we can simply equate the coefficients in front of each sine x and cos x on either side of the equal sign, leaving us with two simultaneous equations. Now we must exploit some trig identities. To find alpha, we divide one equation by the other and replace the sine over cos for tan, which gives us this result. To find r, we must square each equation and add them together. Once we factorize out the r squared on this side, we have the nice realization that sine squared plus cos squared is equal to 1, and so we can just write that r squared is equal to a squared plus b squared. From this we get the expression for r in terms of a and b. We now have all the information to write out this function in the harmonic form.